Now, to balance equation for the hydrolysis of salt, that's you have this aluminum chloride plus water, then you have this. So you have hydroxide as a base, then you have acid. Then here, ammonium chloride plus water, then you have this base, acid. Then here we have zinc sulfate and water, then we have this, you also have acid. You can see that the products are similar in the sense that we have the dominance of acid and what? The base. So depending on the what? Concentration. So in that situation, deduce the properties of acidic, basic, neutral. So what accounts for acidity is the presence of what? Hydrogen ion. What accounts for basic nature is because of the presence of what? OH. Then when there is absence of both OH and H+, then you can say that such salt is what? Neutral. So let's see UTME question designed for this topic. Now, to talk about the color of indicator in acid and base, which is phenolphthalein. We have phenolphthalein indicator, we have methyl orange, then we have the litmus paper. So in acid base, phenolphthalein in acid is colorless, while in base it is pink. Then methyl orange in acid is red, in base is yellow. While litmus paper in acid becomes red, and in base becomes blue. So these are the various colors of this indicator in acid-base titration. So it should be noted because it will form the basis of the color nature. These are the UTME questions that are designed for acid, bases, and salts. The first question is the hydroxyl ion concentration in a solution of sodium hydroxide of pH. This is, so the question has also calculate the hydroxyl ion. And we know that our pH plus pOH is equals to 14. So automatically, what it simply means is that we have been given our pH to be equal to be 10. So 10 plus pOH will really give us 14. So automatically, what it means is that pOH will be equals to 14 minus 10, and that will give us 4. So pOH equals to 4. So since our pOH is equals to 4, and the question asks us to find hydroxyl ion. So we know that pOH is negative logarithm of hydroxide ion concentration. So in that situation, we have this to be 4. So automatically, we are going to have negative logarithm of hydrogen ion concentration. So which simply means that this then we can write, multiplying through by minus, we have log hydrogen ion concentration to be hydroxy ion concentration rather equals to minus 4. Then when this log comes to this side, it becomes what? Anti-log. So in that situation, we just have, this one is to base 10, so we have our hydroxyl ion to be the anti-log of this, which is 10 to the power minus 4 mole per dm³. So we'll go to our option C, the one that matches that, and that is option C. Then the second question, the pOH of a solution of 0.25 mole per dm³ of hydrochloric acid is, so the question is asking us for the pOH of a solution of this hydrochloric acid. Automatically that means we have been given the pH, we have been given the, because we know that our hydrochloric acid will be, we ionize by H plus Cl minus. So automatically the hydrogen ion in that system has been given to be what? 0.25 mole per dm³, which is also known as what? 1. So in this situation, but we know that our pH is equals to negative logarithm of hydrogen ion concentration. So in the light of that, then we can say that pH equals to minus logarithm of 0.25. Then that means that this will definitely be pH will be, we have logarithm of this will definitely be, let's say, minus log of 25 over 100. 25 here 1, 25 here 4. So we have pH to be equals to log of 1 over 4 minus, then this pH will now be equals to logarithm of, this one will be 4. Because when this one comes here, it will become 1 over 4 raised to power minus 1, which will definitely be pH will be log of 4. Now what is the log of 4? So then log of 4 is, pH will now be, log of 4 is 0.6021. That is the log of 4. But the question never asks us for the pH, rather the what? The pOH. And we know that pH, there is a direct relationship between pH and pOH equals to 14. And since we have calculated pH, automatically the 0.6021 plus pOH equals to 14. Then here we have pOH equals to 14 minus 0.6021. And that will be pOH equals to 13.39 thereabouts, which is approximately, this will be 13.397, which is approximately 13.40. That's our pOH. So automatically we go to our option and see the one that matches that. That's option B. To question 3. Which of the following ions is acidic? Remember that the options are potassium ion, nitrate ion, sulfide ion, then hydrozonium ion. So you ask yourself that what will happen here? So what they are testing here is the Arrhenius definition of an acid, which says that an acid is a substance which in aqueous solution produces an hydrozonium ion. Take note of that. So it's a substance which in aqueous solution produces what? Hydrozonium ion. So automatically the option to that question will be option D, which is because this is the only hydrozonium ion in the option. Then phenolphthalein in acidic solution is, so that is what I represented earlier. So in this situation, phenolphthalein in acid is colorless, while in base it is pink. So automatically it will definitely be option A. Then what is the pH of 0.01 mole per dm³ solution of this? So automatically the pH of 0.001 mole per dm³ of this. So that means it is, we have been given the OH as hydroxide ion to be what? 0.001 molar. As molar. Capital M. Then in this situation, we know that there is a relationship between pH and hydrogen ion concentration. This concentration of this times the concentration of this is equals to what? 10 to the power minus 14. So automatically what it means is that concentration of hydrogen ion times, because this one being multiplication, and this one is 1, 2, 3. So that's 1 times 10 to the power minus 3 is equals to what? 10 to the power minus 14. Then we have hydrogen ion concentration. We definitely give us, we divide both sides by 10 to the power minus 3, and we have 10 to the power minus 14 divided by 10 to the power minus 3. So that will give us hydrogen ion concentration to be equals to, if this one come up, we have 10 to the power minus 14 times 10 to the power minus minus. When this one comes, it becomes minus minus. And here we have hydrogen ion concentration to be equals to 10 to the power minus 14 times 10 to the power 3. And by law of indices, we
know that when you bring this together, since you have the same power and the same base rather, and there's a multiplication sign, we had the index. So we have 10 to the power minus 14 plus 3. That would definitely give us 10 to the power minus 11. So now, is the question asking us for hydrogen ion? No. The question asks us for the what? The pH. And we know that pH is the negative logarithm of hydrogen ion concentration. So that means we have our pH to be equals to minus log, then we slot in our hydrogen ion concentration, which is 10 to the power minus 11 molar. So from this point, we have pH equals to minus log of 10 to the power minus 11 is minus 11, and that will give us pH equals to minus 11, and that is plus 11. We want to have our pH to be equals to what? Plus 11. Now, question 6, mathematical expression for pH. For pH is, so we know that our pH is negative logarithm of hydrogen ion concentration. So it should be borne in mind that this H plus, concentration of H plus can also be written as H3O plus in terms of what? Hydrozonium ion. So definitely what it simply means is that we can write pH to be equal to minus log this is the same. So in this situation, in the light of this, then this one can be written, this is just simple mathematics. We have minus log. So the rule here is saying that when you have a log p, is the same thing as log p raised to the power what? A. So also I will